at your school, or a little bit of both if you're one of those schools about to enter the hybrid model. Um, I just want to thank you for joining us today, just because I know that time is a hot commodity right now, and so I thank you for spending an hour with us this evening. If you haven't, and hopefully you already have registered into QuickBase, following the webinar, I will get the registration information or the attendance from our friends at Need, and I will be in charge of giving you your PLU certificates. So once again, thank you for joining all of us, and I look forward to learning with you, and I'll let Emily take it away.
Hi, everyone. Thanks, Lauren. As Lauren said, I'm Emily Hallbaker. I am from the National Energy Education Development Project, which is all short for NEED. You can just call us NEED. And we are happy to partner with DC's Office of the State Superintendent and some of the schools in the surrounding area to work on what we call our Energizing Student Potential program, which is a partnership with PEPCO, your local energy provider. And we decided we wanted to show off some fun little activities today that you could do with your students. And the theme is spooky. Nothing is really Halloween-y today, but all of the materials have some sort of Halloween material related to them, so that you could maybe use up some things your kids might have at home or may have around, and they have sort of a spooky element to them. So I just posted in the chat, if you have access to that. If you're on a phone, it might be difficult to see, but if you are on a device, you should be able to see both of the activities that I'm going to be sharing with you today as PDFs in the chat. You should be able to view those. If you're not able to view those, don't worry, I will share those with Lauren, and she can share them out to you as well. Both of these activities you can also access through a link I'm going to pop in the chat, and I'll share that with you shortly. We are a national energy nonprofit. We work with students K-12, teachers of all walks across the country, and even some internationally, to focus on energy education. So these activities that we're going to do today, you can download for free. All of our materials are available free for you at any time. You don't need a password or anything, and you can feel free to share with folks at any time as well. And between the two activities, I will take a quick break and show the website and share with you how to access the two activities that we're doing today and other additional content that you might find interesting in the future. So today's first activity, because I'm very food motivated and your students might be as well, our first activity today is called Candy Collector, and I believe in the information you were given, there were materials if you wanted to sort of gather those items. I'm gonna put myself on speaker view here real quickly, and I'm going to, okay, there we go. The first activity is called Candy Collector. And so this Candy Collector activity might work really well around this time of year for Halloween, because your students might have candy handy. And so if you're teaching virtually and kind of wondering what you're going to do in the next couple of weeks while the kids are going back, this activity is a good way to introduce two important energy terms that your kids might hear on the news, they might hear in the world around them. And those terms are renewable and non-renewable. And so when we're talking about energy sources, things that we use and harness to provide us our energy, we classify them in one of two categories, renewable or non-renewable, based on how we can access them and how quickly they get replenished into our environment. And so this activity is going to help sort of introduce that to them. And bear with me, I'm kind of working on like a rudimentary camera system. Normally we have some fancier tech, but today I'm working sort of low tech, which might actually work well for you all because you might be in a similar situation to do this activity with your students. So with Candy Collector, what we're going to need is candy. And you're gonna need 2 types of candy at minimum. And so the 2 types of candy that I'm going to be using today are M&Ms, because we have them available. Roughly 50 of these. You could use more, you could use less, depending on how you want to amplify the activity for your students. I'll talk about that in a second here. But I've poured like 3 little fun size bags in this container here. That's roughly 50. I do the teacher move, like poker chip it, and I count out 50 in one bowl, and then I do the rest to make it look about the same. So if you're doing this in the classroom, that might be a nice tip. Only count 1 time, don't count 56 times. That seems like a nightmare. Or you can know like, hey, roughly this 3 of these is 50, so you're good to go. You will need 1 other type of candy that looks maybe a little bit different. A lot of times for this, in the activity instructions, we'll say jelly beans. Today I'm using little mini gobstoppers because, again, it's what's in the candy variety bag that we have in the office. So these are little mini gumball-y type items that we'll use in a second. But I'm going to set those aside for now. And we're just going to deal with our M&Ms, our bowl of M&Ms. And I will kind of tilt this way so you can see. Okay, and I'm going to need 3 containers. So in this case, I'm using a bowl. You could use a paper plate, a regular plate, a paper towel, whatever you have handy. And your students would need, if they're doing this individually and you're going to guide them through the activity, you would need 3 receptacles of any shape or size. I think these paper bowls are pretty easy, or paper plates are pretty easy, because it's great for students to navigate, especially if you have younger people. But you could use cups and things of different sizes to make it more of a challenge if you desire, okay? So to set you kind of up for some context here, and sorry, I'm dealing with the mouse and the 3 bowls. We're really only going to use the 2 to start here. Okay, our 2 bowls, what we've got is we're going to set this stage as if we are a town. And in this town, we are new and we've just settled in our in this town historically, and we need energy for our town. And this bowl right here is going to provide us our energy. And so as a town or as a community, we are going to each year look at how much energy we're able to produce and see how long that energy is going to last us in our environment. So the way that we would set this up is we'd have students, and if you're working in the virtual world, your kids could all do this individually at the same time simultaneously, and you could facilitate them through the activity. And so if you're doing it back when you get into the classroom, obviously with COVID situation, you'd probably still want them to be spaced out and working individually. So each student would receive their own bowl in this situation. And so you would give them an amount of time. At the end of each of those amounts of times, they will sort of evaluate how they've done at recovering their candy. And so couple rules and regulations here. This is all discussed, and you're given sort of a little script here on this sheet, on the instruction sheet that I posted in the chat. So it'll set you up for success in that way. You don't need to provide it to your students, so it's completely authentic to them participating. But what you're going to do is you're going to tell them that when the time starts, they're going to have to move candy from one bowl to the next. And this is their earth. They're going to have to take energy out of the earth and put it into their energy storage facility where they can store energy until it's going to be used. And the way they're going to do that is with only the tools provided, because it's early on. We don't know a lot about what we'll need. The tool provided is going to be a straw. Now, if you're doing this with students at home, they may have straws at home, they may not. If they don't, encourage them to make their own using a scrap piece of paper. All they need to do is roll it up. Or you can have them use reusable straws, all kinds of different things that they may have handy at home, but they would need one straw. And if you want to be a stickler about instructions, you're going to suggest that they use only the straw. And some people who interpret this, it says only the straw, no hands, so they tell their students that they may not even hold the straw with their hands. So like I said, depends on how much of a stickler you want to be, but I will demonstrate. They would have to do something along those lines. And then they're going to drop their candy into the next receptacle using only the straw. Okay, and you're going to give them a certain amount of time to go through that. And if you have these materials and you want to do this with us and you want to show your face on screen, I really appreciate it. Otherwise, I will just continue demoing myself. And I would go through a round. And so what we would do is we would start, and there's 2 rounds of this game. We're going to do the first round where we go through a couple years. Each year on the instruction sheet is about 15 seconds. So you'd have your students set this up and they'd go through 15 seconds on the clock, and they'd see how much candy they can move from their earth to their storage facility. After 15 seconds, they would go ahead, you'd tell them to stop. They'd set their tools down, they'd set their straws down, and they'd count how much candy they recovered in their storage facility. You'd have them count it, maybe have them keep a tally. You could have them enter it into, if you are using sort of the Google Suite or something similar, you could have them enter it into a class spreadsheet so you can look at each other's data and compare. And you'd have them maybe even start making a bar graph or a line graph, depending on your students' capabilities and graphing knowledge and what they're learning about. As far as graphing, obviously, if we're doing rounds over time, a line graph is appropriate, but maybe a bar graph is more appropriate based on your student's skill level and math capabilities. So you'd have them count up their candy. And in this case, I got 4 in my first round. We'll pretend that that was one whole round. After they've counted, tallied them up, maybe done their graph a little bit, you'd have them take any candy they recovered in bowl 2 and put it into the third bowl, which is their discard bowl, and they set that off to the side. An important designation here is that you don't want them to eat any candy until they're completely done with it. And maybe during a time when we're concerned about the spread of germs, maybe you tell them they don't eat any candy. Best wishes with making that note to your students, especially if you're using candy. If you want to use non-candy items, you can use things like bingo chips, and then hopefully they wouldn't eat those. So we would have them, like I said, discard all of their candy that they recovered and used after 1 year, and they'd set it aside. Then we'd set up and have them go through a few more rounds, 2, maybe 3, maybe 4. And depending on how good your students are at this process of depositing candy, I'm not so good at it. After 15 seconds, several times, they may deplete their bowl completely. Some of them, it may take them a good bit of time to empty their bowl, a good number of years. And what you can do for older students who are familiar with doing graphs, you could have them, and if they're working on algebraic equations and slope of lines, if they created a line graph, you could have them calculate the slope of their line after a few trials to determine a prediction for how long their candy would last. For students who are just learning to make inferences, you could have them look at a table of how their harnessing of energy from round to round has gone, and they could tell you what they think patterns they might see are, and say most students will find, for example, that after year 1, their candy that they recover might go up a little bit. And then year 2, it might go up a little bit because they get better at it. Some students might find that it goes down, and you can talk about why they have fluctuations from year to year. But you want to have them kind of work through figuring out or guesstimating maybe how long their energy will last, how many years their energy will last, and have a discussion with them about how that might affect their town and what they might need to be thinking about and how they might need to deal with energy if they are depleting it faster than they're getting it back, because nobody's put any candy back into their bowl. Okay, so that's sort of the phase 1, round 1 of this activity. And so after a few rounds, after that discussion, after thinking about what will happen if you run out of energy, we're going to reset the stage. and sort of come back to our original bowl. And we're going to put all of our candy, whether discarded or stored or whatever, back into our first bowl. And we're going to call this phase of the activity or round of the activity our modern day phase. And in this case, we are going to have our candy all in one bowl, but we're going to say, okay, so it's modern day. We realized that maybe we were being a little wasteful with our energy, and maybe we have some technology that helps us save energy a little bit better. So now each person only needs to recover 2 pieces of candy each year to be a functioning town. And so they're going to know to start this new round that they only need to get 2 pieces of candy in 15 seconds. And the other thing that we're going to do, aside from putting a stipulation onto it, is we're also going to say we're adding new energy. And in this case, I've unwrapped my little gobstoppers and I've added 2. You could have them add 3, you could have them add 4. Again, depends on your students, maybe their manual dexterity, depends on the group that you're working with. For older students, you could designate a variety of different numbers of candy to kind of talk about some differences in energy resources based on place to place. But in this case, I'm going to add 2. Instructions say 2 to 3. So have each person or each group add 2 pieces of a new type of candy. You want them to look a little bit different so that they're easy enough to spot. And you maybe want them to, they can incorporate a little more of a challenge. So if they're a little bigger, in this case, the gobstoppers are a much different shape. They're a little more round. They might be a little harder to recover. And they might be a little easier to recover. You can add that element in as well. And what we're going to do with this is we're going to have the students repeat the process. And again, with that stipulation that they only need to take 2 pieces of candy out. And so we'd have them go through this again and recover their candy. I got a gobstopper this time. Success. And we want to try and encourage students not to have spills. We want to try and encourage them to get candy from one bowl to the other strictly. And at the end of each round, 15 seconds, you'd have your students again do a count and say, okay, you got your 2. If you got your 2 in 15 seconds, you're going to stop at the end of that time, no matter whether the whole year of 15 seconds has passed or not. If you got your 2, you're good to go. You don't need to get more. And you'll have your students put them in, and they would then, once they have their 2, they'd start their tally again, and they might be like, why are we doing a tally? We're only going to have 2 every single time. That's correct, but we're still going to try and make a prediction of how long our energy is going to last. And you're going to have them put their M&Ms in the discard bowl, just like you did the first time. You're gonna have them move the M&Ms out to the 3rd bowl. But in this case, on this new modern day round, I had recovered 1 gobstopper. And in this modern day round, before we go to the next one, what we're going to allow is that our students put this back in our original bowl. They can replenish any gobstoppers or jelly beans or new type of candy back in their original bowl. Okay, and so for any subsequent rounds, your students might develop some sort of mental note. Oh, if I can replenish them and I want them to last longer, I'm going to keep trying to go for those gobstoppers so that my candy lasts the longest. And you may want to ask them, what can you do to make sure your candy lasts as long as possible? And you'll have your students do another round, and they might find, for example, in my case, that candy is the new candy is super easy to recover. So I'm going to tackle it first. For some students, depending on what they have accessible or what shape their candy is, if you use jelly beans, for example, the jelly beans, that bean shape, sometimes makes them a little tougher to get out of the container. So students have a need to kind of grab it correctly with their suction. And I'm trying to be graceful as possible in my vocabulary here, understanding that we're working with students. So you ask them about it. So if you tried to go for the jelly beans or the gobstoppers and it wasn't working, and you didn't recover only those items, what happens? Well, you're going to run out of energy just like you did in the previous round or the pre-present day round, because they're too difficult to get out. And we're going to have them keep replenishing and seeing how long at the rate of consumption that they're using them right now, they think their energy would last. And then to close up shop, you could go a couple rounds before you have them look at either the graphs or the tallies that they've made. If you're working with older students who you've had in the pre-present day make a line graph and you want to have them kind of look at the lines and compare them, they're going to probably notice that their line is sloped drastically differently in present day than it was in the prior round, because they're not increasing or decreasing. They might end up having a pretty flat line. And you can talk about why that is and why that might be good in this case, if you want to make your energy last as long as possible. You can talk to students about maybe strategies that they had, challenges that they had, and sort of think about how they might relate those to us as a society when we're trying to harness energy. If we just need it and we don't have enough, we're going to go after whatever we need and whatever's available, and we're going to take it out and we're going to use it. If we have the luxury of using things a little more wisely, we might be a little more choosy in what energy sources we're going after. And we want to ultimately have the discussion with our students. If we can define the terms renewable and non-renewable and ask our students, okay, so which candy is which in this activity? And if you haven't introduced these terms to your students, it might be a good time to have them create an operational definition and have them say, okay, these are energy sources. Energy sources can be described as renewable or non-renewable. Which candy in this activity represented renewable based on the structure of the word renew, and which one represents non-renewable, and write a definition for what you think those two words mean, and then discuss it with your students to have them kind of come up with the terminology and get towards the idea that renewable energy sources are energy resources that we can replenish in a relatively short enough time span for us when we're consuming them. Renewable resources are things like wind, solar, hydropower, or water power. Biomass, things that were once living like wood, waste, and garbage. And those things are things that, based on natural processes, are replenished daily, minutes, hours, even weekly, or in shorter number of years. Whereas our non-renewable resources, are the M&Ms in this activity, might be things like coal, petroleum, natural gas, propane, or uranium, things that require large geologic processes and formations over many, many years, talking about thousands to hundreds of millions of years to replenish based on the processes that create them in the first place. And so this activity, again, is meant to introduce your students to these terms, get them thinking about energy, get them thinking about energy sources. Does anyone have any questions so far before we talk about further application?
Hey, this is Lauren. I was just wondering if you wanted to modify this with younger kids, just because I was looking at Tia's poster when we started.
Thank you, Lauren. I was going to ask, I was
Circle
like, well,
time.
I was over here making little notes of how I could make it more, kind of lower level for them. But definitely the challenge of trying to just exert the energy and move the M&Ms, I think they'll enjoy.
I was thinking about like maybe using tongs, but I'm wondering if there's like a bigger candy or a bigger even like, even if you
Well,
don't use a food item, maybe like squishy balls or something like that. I'm just trying to.
yeah, cereal, squishy balls, marshmallows, and pretty much
Oh, marshmallow's a
anything.
good one.
Um, and we do a lot of like sorting and grouping, and so this could definitely fall like right up under that category. So,
That'd be a great adaptation. Another thing that I would suggest, you could use larger objects. You could use tongs. especially for students who don't have that dexterity and sorting and things like that, I would give them a shot to try it. We've done this with some pretty young students, and they seem to do okay with it. One quick modification that I do even with adults is I can up the time limit. So I give students, instead of 15 seconds, I give 20 or 25. And sometimes that helps in the first round, at least, for them to get comfortable with it. I am never a stickler about holding the straw. I let them hold the straw because I think it promotes spills and too much messiness, and I'm not a mess creator normally in the classroom. So, options. Bigger candies can work, but with caution, because the challenge here is if you have a bigger candy, it's going to require more suction. And so that might actually make it more of a challenge for the kids to move from one bowl to the other. M&Ms or Skittles, that size of candy seems to work pretty well once the kids get a hang of, sort of, in my case, I try to make sure I get it right where that M is on the flattest part of the candy. Same with the Skittle. I've had teachers who use, conversely, to modify it upwards. Apologies, Tia. But I've had teachers who use a variety of different candies, so everything from M&Ms to Starburst, and each of those different types of candy in the bowl is going to represent a different type of energy source. And then the kids would look at the breakdown after each year of how much different energy sources of each type they recovered or utilized. And so that's sort of an upper level adaptation. The only thing I would say is just whatever you put in bowl one for round one, make it uniform for younger students, because that will make it a little more simplified for them. But absolutely, maybe like little Nerf balls or ping pong balls might be a good sized item for students to use with tongs. And they could even use their hands with gloves on if you needed to modify for germ reduction in this case. And you could, if you wanted to do it on a larger scale, I'm thinking sort of like, I'm aging myself here, but like a double dare kind of situation. You could have them move it from one desk to another in that time, so that, if you're going two bowls side by side and they're big items, your kids might be just depleting their bowls very, very quickly, and you might need a ton of objects in this first bowl. But if you had to have them cross some space with it, that might be a nice way to limit how many supplies you're going to need, as well as, still address the idea that there's a challenge involved with recovering and consuming the energy initially. Does that help a little bit? Hope so. Any other questions there?
Yeah.
Okay, one other adaptation you could do if any of you are working with older students or students who are getting the hang of it, to kind of bring in some sort of current event ideas and things like that, you could have each student represent or talk about how, if they were given, so if I gave Lauren, I gave Tia, I gave Grace, I gave each of you differing amounts of candy to start with, and how that affects the amount of time your candy lasts, and what strategies you might each employ to make your candy last as many rounds as possible. That might have your students kind of thinking about things that they might hear in the news. So certain countries have less energy sources available to them based on geography. Certain states have different amounts of energy sources available to them based on their geography. In DC, for example, use biomass. You use a little bit of solar, but a little bit of natural gas, but everything else that you use, or what you produce in the city of DC is not enough to support the whole city, so you must bring it in from elsewhere. And so what kinds of strategies places need to employ to make sure that they are using their energy wisely and not having to rely on other places, and what that means when you need to rely on someone else to produce the energy that you need and you use. And that can kind of get students thinking a little more about the cultural awareness a piece, and a little bit more of the geography and social studies side of things. Any questions? Okay, awesome. So I'm going to take a quick break from activity, and really briefly, I'm going to share my screen, and I want to real quickly show you our website, and hopefully you're able to see our NEED website, need.org. All of the activities that we have available, we have over 130 titles at need.org that we have put together for students across all grade bands, K to 12. And all of those items are free for you. So when you go to need.org right now, the very first thing that you're going to see is, much like a lot of websites, a little announcement about how things are going, considering we a lot of times do in-person events, trainings, student activities. And so knowing that the folks that we're working with, like you, are kind of up in the air about what's happening, and it's virtual, but it might be hybrid, it might be this, it might be that. We want to let you know that there's lots of resources and activities that you can find that might support whatever that setting will look like. So I'm actually going to go here first to our distance learning page. And one of the things that you'll be able to see very quickly is how to navigate this page, a little video about what's on this page itself, but then all kinds of tabs here to showcase some things that we have that might make your planning go a little more smoothly. So the first thing here is energy ed tech and links. So if you're somebody who has to use a lot of video clips and a lot of engaging digital activities to keep your students functioning and to keep that lesson moving, we've got some opportunities and options here for you to show off those examples. We have an entire YouTube channel with digital or videos of lessons that we've done, career profiles of folks in the energy industry, all kinds of things like that that you could use as standalone activities for your students, especially if you have to, hop out and you need a sub for a few minutes, you have to show a video. You can access our YouTube channel with experiments and all kinds of fun activities. We have a teacher share-a-thon page where you can see what other NEED teachers are doing and using and how they're applying our materials in the classroom. We also encourage you to share things with us. So if you're doing anything energy related in the classroom and you want to show it off, send us an email and forward it on, and we'll feature you. Games and activities, especially for you with younger students. One of the things that I love to share with folks right now, we have our carnival games, we have info book activities. Those are printable, but some are also digital, like fill in the blank, crossword puzzle kinds of situations. But we also have, especially Tia, I think this might be fun for your students, we have some energy themed coloring sheets, including some Halloween focused ones that might be fun ways to sort of introduce some content in a cute way to give your students something to work on while they're listening to you or doing circle time. They can engage in some coloring at the same time. Also, we have lots of lessons that would be easy to implement in the virtual realm, some synchronously, some asynchronously, and some a combination of all of the above. And then some wonderful links for you as well to other sites and places that are doing things that might support the classroom environment that you're working in. All of our materials, if you want to download them, I'll show you where to access that really quickly. But the first place that I would say to head to if you need anything would be our educators tab. And here you can find, again, the distance learning resources that I just shared, information about professional development. So if you want to attend another training, if your school is letting you out, I know Lauren would probably help you and support you to get to a training if you'd like to. We have lots of virtual trainings happening around this time and into the winter months as well. You can access all of our curriculum, any kinds of student resources that you might need, curriculum correlations. You can download NGSS, you can download DC specific information that you might need, like the environmental science standards, information about after school programs, any imagery that you might want to add to your own presentations. All of our graphics that we produce, you can download from our graphics library. And then our awesome extras, you can find pre-created PowerPoints, our coloring book, all kinds of things like that, and our awesome extras page as well. So I'm actually going to head here to curriculum, and this is going to send us to our curriculum landing page where you can download curriculum by grade level, by topic area. And so today we're doing general energy, so I'm just going to head to the general energy sources page. And all of our curriculum is housed within our shop. And shop is a tricky word because it implies that you need to purchase things, but as I said, all of our curriculum is downloadable for free in PDF format. So some of our materials you can purchase physical materials to support the guide itself, the student activities and all of the handouts, and all of that is housed in this one spot. So Candy Collector that we just did, you could find, so if you wanted to find it, you type in Candy Collector in the search bar, and it would bring up any title that that activity is found in. And that the activity that we did today comes from Energy Games and Icebreakers. And all you'd need to do is add this item to your cart, and you'd click check out. And by checking out, we just want to have your email address so we can send you a copy of the PDF. And we can also let you know if we've made updates to it, because all of our curriculum gets updated annually for statistical relevancy, but also for efficacy purposes. So our teacher advisory board looks at and improves all of our materials on a regular basis. And so we want to let you know, hey, we've done some things to this guide, or we've added some activities. And so you could find Games and Icebreakers here. All of our materials are also downloadable as an e-publication. So if you are sharing these with your students, you could send them, in this case, you wouldn't necessarily share that with your students, but you could download it as a book that they could read on a tablet quite simply. One of the things that I think would be lovely to share with your students, specifically that you can download directly from our website, but also from this shop, our elementary energy info book. For Tia, you could also download the primary version. And so I'm going to head to our info book, our info book page. Apologies. And you can download all of these here. Our info books are sort of like a text on anything energy. So they're a student informational text on all of the energy sources, how we use energy, what we do with it, environmental ramifications of using energy resources, advantages, disadvantages, all of those things. And you can download all of these here. And so all of our activities, like I said, downloadable from our website. Another cool thing for those of you teaching virtually, if you do want to share our info books with your students, they are also on our students page within our website itself. So if you head back to the students tab, you can actually send them directly to the energy info books page or link to it from your website if you'd like. And say you want to talk about biomass, because we talked about trash and waste and poo, because kids always love to talk about poo and how we turn that into energy. You could link them directly to our biomass page, for example, or the wind page, or electricity. If you wanted to talk about historical scientists who dealt with electricity, you could send them directly to the electricity page or history of electricity page. So all of these things are here. We have many more resources on our website. I don't want to take up too much more time on the website, but I encourage you to check it out. I encourage you to email us. You can also contact us from this contact button if you have any questions. And also encourage you, if you are a social media person, check us out either on Facebook or Instagram, Pinterest, and Twitter. We share articles, but we also share fun things that we're doing. We will more than likely post a link to this video of this activity today on our YouTube and probably one of our other social media sites if you're interested. We post about new events, we post about free things that we're doing, and all of the like. So it's a great way to kind of keep in contact with us and find out what's going on and what might be worth checking in on in the future. So I will stop sharing the screen again, and I'm gonna briefly just kind of go over our last little activity. We are sort of getting towards the end of time here. In our last little activity, I'm gonna turn my screen to the side here, and I'm gonna do a little setup. And our last activity, not so spooky. Spooky makes it sound ominous, but it's greenhouse in a beaker. And so one of the things that we have teachers asking us a lot about at all ages is how to talk about climate with their students because it's in the standards. And so greenhouse in a beaker is one way to cover that. And the greenhouse effect is a natural process that occurs. It's actually a process that's very important on our planet to keep us warm enough to sustain life. And the greenhouse effect is basically the concept of putting plastic wrap over your food. Our atmosphere is built or made up of several gases. These are gases we call greenhouse gases. And these gases are really good in our atmosphere at trapping heat. And the right concentration and the right mixture of gases keeps us at a temperature and helps us as light comes through from the sun, bounces off the earth, and tries to head back out into space. It's trapped in by this sort of blanket of greenhouse gases above us. That mixture of gases that we have on Earth is good at trapping the heat at the right amount that we can sustain life. It's not too hot, it's not too cold, and we can do the things that we need to do to grow plants, to breathe oxygen, to do all of these things. So we need the greenhouse effect. However, we have on our planet something called the carbon cycle that naturally processes gases in, gases out, specifically carbon dioxide. And so when we're adding gases, the right kinds of greenhouse gases back into the atmosphere at higher amounts than would naturally occur through human activities, we could alter how the greenhouse effect works. So this activity kind of aims to show students what the greenhouse effect does and sort of sets it up in a beaker. So on the materials list, I realize a lot of you may not have glassware at home. So one of the things that I would suggest, and on the materials list, I said to use cups. Mason jars work really well. These are plastic beakers. You could use sort of, to use a bar term, you could use like a sort of a rocks glass that you might put a dark beverage in with some ice. That should work for you. If you have sort of like a large juice glass, you're gonna need, if you don't have a flask, one of the things that you could use as an alternative is a coffee mug with a flip top kind of lid on it. And in this case, I'm gonna use a stopper to go in my flask. If you used a coffee mug, it would have an opening in the top that you could put the hose down into, and the hose would come out, but not all of the contents inside, okay? So I'm gonna use a flask. If you have a coffee mug, that works really well too. So what we're going to do in this beaker setup is you're gonna need 2 containers. For science purposes, you'd like them to be the same size and shape and color for your students to showcase proper variable control. You're gonna need 2 thermometers. I'm using sort of fairly inexpensive meat type thermometers that you might use in the kitchen. You can find these at the dollar store. You could use analog thermometers if you dare with your students, right? Because teaching them to use an analog thermometer anymore is quite challenging. But if you have whatever you've got, you can use. And you're going to need water. You're going to need whatever this receptacle you're using is. I'm again using a flask. You could use a coffee mug, a travel coffee mug. And I have a lamp. And in my lamp, I'm using a work bulb. And this work bulb is an incandescent bulb. So Thomas Edison style bulb with the filament. You could use a heat bulb. You could use something that you might use with your reptile. It just needs to be an incandescent bulb in my lamp, okay? And I've got this tubing coming out of the flask, or coffee mug in your case. And in it, I have about 120 milliliters of water. The only other thing I'm going to need or use is Alka-Seltzer for this activity to create carbon dioxide. Now, If we're thinking spooky science, if you have a fog machine, you could also use dry ice left over from your fog machine. That would also showcase the same effect. But what we're going to do is we're going to set up a situation where one of our beakers has just air in it, and the air that we're breathing has a mixture of carbon dioxide, water vapor, nitrogen. But then we're going to have another beaker that has that air in it, but also receives carbon dioxide. And the carbon dioxide is going to come from the water in our flask, and that water mixing with Alka-Seltzer that I put in to create the bubbles, which are going to be carbon dioxide. So you could also do baking soda and vinegar in here to create the same application if you don't have Alka-Seltzer, if your students don't have that. And then what we're going to do is we're going to have this beaker right here with the hose receive all the carbon dioxide, and this beaker receive none. And we're going to turn the thermometers on, and we're going to train the light on them to see how the temperature might be different in the two. And this would be to kind of demonstrate atmosphere with normal amounts of carbon dioxide, atmosphere with excess amounts of carbon dioxide. So right now my two thermometers are actually reading the same temperature of 74.7, okay? And I'm going to have to hold the light on, and that light is going to come right back on you, which isn't fun. But, so I'll go down from the top. And I'm going to do that and put our Alka-Seltzer in the flask, okay? So if you're setting this up not like I am, right? And you are doing this ahead of time and you have a little more space, it might make sense to kind of have the light fixed on it. But for our purposes today, you would have to look straight at the light, and I don't want you to do that. So I'm going to plop my carbon dioxide in, my Alka-Seltzer in, and right away you're going to see that it starts fizzing. I'm going to put the stopper on so it traps the carbon dioxide in, and the only place it can come out is the hose. And I'm going to sort of angle these away and train the light onto the two beakers at the same rate. And I'm going to share with you the temperatures over time. And this is a little bit like watching bubbles explode. But what we're going to see really quickly is that the temperatures are going up in both beakers, but the temperature is going up at a faster rate in one beaker over the other. Does anybody want to hazard a guess which beaker that might be? All right, I will share with you that this beaker with the hose of carbon dioxide has a temperature at this moment of 79.5, and this beaker has a temperature at the moment of 78.3. They both started at 74.7. So they've both gone up about 4 degrees just with this big bright light on them, the sun in this case. But one has gone up at a much higher rate and will continue to go up until all of the carbon dioxide bubbles have dissipated in this beaker. And so what this activity is going to demonstrate to us is that by adding carbon dioxide to this beaker, the carbon dioxide helps trap heat. Why it does that is because of its molecular structure. Now that's a higher level discussion. That's in chemistry for students. If you want to get into that with them, you can. It has to do with the bonds and the way that bonds are formed in carbon dioxide. But more to the point here, what we want to share with our students is that carbon dioxide is a greenhouse gas. It naturally is going to help trap heat in at a higher rate than other items. If we add excess carbon dioxide to hit at an NGSS and standards-based term, we've got a feedback loop. And if the loop is automatically running on its own, but we overload one part of the loop, how does that affect the future feedback in that loop? And what happens to us if we overdo the amount of carbon dioxide in the atmosphere? Now you can repeat this with your students and take the light piece out of it and look at how the temperature changed. is. And what your students would see is if you live on a planet that has an atmosphere made up much like ours, but you live far enough away that the sun isn't there, that blanket of gases isn't going to do you as much good. So we need a certain amount of these gases, but we want to watch how much of those gases we're putting in just because of how they behave. And so this gets into the behavior of those greenhouse gases and kind of gives your students an idea of what we're talking about when we talk about the greenhouse effect. And you can relate it to an actual greenhouse if you want to have them explore maybe the National Botanical Gardens, for example. The way that greenhouse works is even in the winter, you can grow something like a poinsettia, which would actually grow in a tropical climate. You can grow it in DC in the botanical gardens because that greenhouse wall helps trap in some of the light that came in from the sun and traps it. It transforms it from light into heat and keeps the heat inside so that that plant can thrive. We need those gases to do similar things for us on this planet, but what happens when we have too many? So that's our spooky, mostly because dry ice is spooky and makes carbon dioxide. That's where I was going with that in the title. But things that you could do at home to really show some actual science for your students. This might be a great demo for the classroom here. This might be a great demo to do, or video if you're doing maybe some asynchronous and synchronous activities. Maybe give it to them ahead of time to watch as a video. There are also plenty of videos of this from partners of ours across the web. And one of those is the Paleontological Institute in New York. They do a version of, they do actually our activity with the coffee mug that you could check out. And share that with your students as well. But we have a version of this also on our YouTube page. So I encourage you to check this out. I encourage you to head to need.org, and I definitely encourage you to email us with any questions should you need it at any time. Does anybody have any questions about the two activities that we did, specifically greenhouse and a beaker, since we covered candy collector before?
I don't have any questions, but I did start to.
I had a question about whether or not the temperature would change at all if the sun weren't shining.
Right. So part two
would just change the amount of temperature without the sun shining on it.
So actually part two, and that I kind of referenced it, but running short on time. I want to be mindful of all of your time. Part two of this activity is actually nighttime. So you're going to do the same setup. You're going to empty everything out, start over, and you're going to do everything the exact same way, except you're not going to use the light. And students are going to look at if the temperature changes. And what your students are going to see is there's no temperature change so long as the light is not part of the situation, right?
Yeah.
So you could have them set it up and do it without the light, with the light, and without the carbon dioxide. And what they're automatically going to see is that the things combine together to make that sort of perfect storm, if you will.
Yeah, fascinating.
Great question, Grace. Tia, did you have a question?
No questions. I'm just having a real good time over here exploring the need guides and things. And we do creative curriculum. So we're doing a building study. And then I saw the little gingerbread project and it's like, check out our building study guide. And I was like, okay. So I appreciate you. Thank you. It's been
yeah, if you're doing a building study, the gingerbread house would be great for, holiday topical kinds of things.
Absolutely.
But if it comes out in the wash that you don't get to do it around the holidays, I would check out School Energy Inspectors.
Okay.
And that's our curriculum that is building study related.
Awesome.
That covers efficiency and conservation for students
Awesome.
in the lower elementary grades.
That's cool because we do take walks. Well, when we were in session, pandemic prior, we would inspect our building and go around and look at the bricks and the lighting and everything. And so that's pretty cool. I'll just have them be home inspectors. And so we'll modify it and it'll be fun. I'm going to look that up now. You said it was school building inspector unit?
I'm going to type it in the chat here for you.
Okay, I appreciate
School Energy
that.
Inspectors.
Oh, okay.
And there's a kit related to that, one of the things I would say is if you take a look at it,
Okay.
and Grace, same for you, there's a version at whatever grade level you all want that kind of follows that same theme. And if it's something that you're interested in, I'm going to type another link in, need.org/ESP. We do our Energizing Student Potential program that I had mentioned is a partnership with PEPCO and DC schools, as well as Montgomery and Prince George's County,
Okay.
to teach energy content within the classroom. It's a grant-based program, and that is a part of the curriculum offerings, and we actually provide that kit to schools, and we do sort of like a building study with our certified energy manager. So it might be something to check out if that sounds interesting to you. We would love to maybe talk about how we can incorporate you in.
Thank you.
Grace and Yessie, if you have any questions, please let us know. Otherwise, we're at time. I don't want to hold you up any longer. I really was so glad that you all could join today.
Thank you so much. Wonderful.
Thank you. We really appreciate it. Don't eat all the candy at once, everybody.
Thank you, Emily, for taking your time and showing us some really cool energy projects.
Thanks, Lauren, for organizing.
And King says hello.
All right. Well, I will post my email. Yeah, I will post my email address as well in the chat. If you all have any questions, you can email me personally. You can email us through the website, whatever comes up. You can also contact us through Lauren. She knows how to reach us. Otherwise, have a wonderful rest of your week. Good luck in the next couple of weeks as you kind of shake out what's happening with your kiddos and with your classrooms. And happy Halloween, everybody. Thank you all.
Thank you all.